Okay, so the ball itself, so we're going to kick the ball 20 meters per second, 30 degrees. The ball itself is going to take a parabolic path, something like this. So if you throw something in the air, right, I throw this ball in the air, you can see the path that it's taking takes a parabola, right, parabolic path. All right, so anyway, let's have this ball land on the ground. Like this. So some things that I could ask, questions that I would ask would be something like this. Say letter A, how far does the ball travel? How far does the ball travel, say, in the air? This is sometimes referred to as the range. So if you see a question that says, what is the range? That's what they're asking for. And letter B, why don't we say, what's the maximum height that the ball reaches, the highest point? Height.
Is it kind of
What?
I was gonna ask, is it kind of the other thing we did last unit or chapter, like where we threw the ball instead of kicked it?
Yep, same thing. So in that case, we just threw it straight up though. So the difference is in that one we threw it straight up in the air. In this one we're throwing it at an angle. Okay, so those are the two questions that we're going to pose here. As usual, how should we start these problems? Okay, pull out what we know. So we're going to pull out what we know. Call these the givens of the problem. We are going to have two sets of givens, one for x, one for y. So VOX, VFX, DX, AX, T, VOY, VFY, DY, AY, T. All right, so here's kind of the big difference that you have to deal with for these angle problems. Remember before we always said on the horizontal projectiles the initial y was simply 0. This time it's not, right? We're kicking it at an angle, so there is a vertical velocity. So what you have to think about is part of my velocity is horizontal. We'll call that VOX. And part of my velocity is vertical. We'll call that VOY. You want some water? So VOX and VOY. So whenever you have these angled problems, the first thing you have to do is you have to break apart the triangle. So actually let me make this larger. So this is 20. So we need to find this side and this side. So how are we going to go about finding the horizontal side? Sines or cosines? Which one's going to work for this adjacent side? Cosine. So what's the shortcut? 20 cosine 30. Equals
what does that say under 30 degrees in the triangle next to the ball? Yeah.
VOX and VOY. Okay, 17.3. And in the y direction, right here, how are we going to find this one? Sine. So we're going to go 20 sine 30 degrees. That gives us 10. So that should be our starting point, right? We're going to go break that apart. So let's go ahead now and look at what else we know. So do we know v final in x? We do know v final in x. What's v final in x? 17.3. And why is it the same? So once the ball's in the air, assuming no air resistance, is anything, once it's left our foot, is anything speeding it up or slowing it down horizontally? No, okay? So it's just in the air, it's only under the influence of gravity, so that's going to be 0. And this will always happen when there's no air resistance. All these problems we're doing, this is going to be 0. Do we know the time? Do we know dx? That's what we're looking for, right? Okay, in the y direction, is this 10? I mean, yes, it is 10. It's v final. Do we know v final y? Do we know delta dy? Do we know ay? Okay, do we know time? Okay, we actually know a couple of these things. Okay, so here's our ball, right? And our ball is going to fly through the air and land here. So what is meant by delta dy? It's how high above or below it is from its starting position. So if it starts here and ends back here on the ground, how high is it above its starting position? 0. So delta dy is actually known. Okay? So this was because it's at the same height. So delta dy is 0 whenever it's at the same height. In v final y, we actually could probably prove something, and we did in the last section. But let's go ahead and calculate v final y here, just so for future problems we'll see what happens. So we have 1, 2, 3 things at this point. Let's use this. Vf squared equals Vo squared plus 2AD. Squared plus, well, since delta d goes to 0, that's just going to be 0. Therefore, v final is plus or minus 10. Remember, when you square root, you have to plus or minus it. What's the right answer? Negative 10. And where did we see this before? When we threw things straight up. Remember, since vertical is isolated from horizontal, then it is going to be the same result. Now, one important note, both of these terms right here, this is only true if what is stated in the problem. It lands at the same height. Good. So make sure you're clear on that. A lot of the problems that we do, it's not going to be the same height. Like, for example, if we have a goalie right here, oops, it's a crazy goalie. If we have a goalie right there catching the ball, then it's not the same height, right? So it's only true if it lands at the exact same height. Keep that in mind. Okay, so let's go for this. How far does the ball travel in the air? What are we solving for? Which variable? dx. Notice we do have 3 givens. Usually that works for us. Is this going to work for us this time? No. And why doesn't it? Because of that a equals 0, it cancels out the d. So, but we're not stuck. What can we do? Find the time. Yeah, we have 4 things over here, so we should be good to find the time. Once we know the time, we know the time, and now we have 4. So why don't you guys go ahead and do that? I'll do it up here as well, but go ahead and solve for the time. Okay, make sure you're using your y variables for the time here. So it's about 2 seconds. And remember, the key thing with time is it's true for both. So x and y is both going to be 2.04. Okay, keep going. We now know 9 of 10. We should have no problem getting that 10th value. So go ahead and solve for it. Put this on the x side. And I think you have your choice of several equations. I like using this one, especially for the x side, because what's the acceleration on the x? 0. So this always is going to result in delta d equals VO times t. Okay, let's do it. Delta d equals V initial is 17.3 times 2.04. So looks like it's about 35. Okay, 35 times 3. Looks good. Yeah. Okay, let's keep going. So that's found the range. Let's go ahead and find the height. So notice in this problem, we have our givens for here was from the beginning to the end. Now we're looking for the top. So some of the things are going to change. So let's just go ahead and redo these, but this time we'll call these to the peak. So VOX, is this going to be any different? No, this is just at the foot, right? That doesn't matter. VOY, is that still 17.3? Yep. Delta dx, is this going to be 35.3? It is half. Why is it half? Because this is a symmetrical journey. And if it goes to the same height, it's a nice symmetrical journey, and so you could say that that's going to be exactly half of it. You do have to be careful. That's only true because we said the same height. If it's not the same height, then that would not be true. All right, what about time? This is also half, and again, same thing. So if this goalie caught the ball up here at some time, you can't just cut it in half. It wouldn't be half. Same thing with the distance. But if it is the same height, then it will be half. So we just found all of our givens, right? But that didn't really help us with the problem, but you could piece it together. Let's do the y direction. Is V initial y still 10? Is V final y still negative 10? No. What's the velocity at the peak? What's the vertical velocity at the peak? 0. Now this is important. At the peak, does the ball stop? No, the ball does not. If the ball stopped, what would happen to it? It goes straight down. Okay? So it doesn't stop. It's still moving. It just has only a horizontal velocity. It just stops rising. It stops rising and then it starts falling. So that's why it's 0. Okay, what about delta dy? So we're looking for, what about A? And what about T? Half. Okay, it's going to be half again, 1.02. And again, this is only true because of that same height. All right, we should have enough. We got 4 things. We're just looking for delta D. Why don't you guys find it for me? But why don't you guys do it without time? Choose the equation without time. because doing it that way will always work regardless of whether it hit the ground or not. It's like about 5 point something.